All right, let's go ahead and talk about um, why some chemical reactions are endothermic and exothermic. And really, we're going to talk about the whole concept of bonds breaking in a chemical reaction being an endothermic process and bonds forming being an exothermic process. And so, all chemical reactions involve the breaking and forming of bonds. All right, so that's what we want to think about. We want to think about the breaking of bonds, the reactants, the bonds and the reactants will break, and then the bonds and the products will form. And so we have bonds breaking, new bonds forming. And like I said, when you break a bond, that is an endothermic process because it requires energy to break a bond. It's kind of like, think about two magnets. If you were to pull apart two magnets, it requires energy to pull those magnets apart. Now, think about two magnets coming together. They actually will release energy when they come together. And so I think that second part's harder to see. But anyways, the energy required to break all of the reactant bonds is a sum of all the average bond energies in the reactants. And this is, again, an endothermic process because energy must be absorbed to break those bonds. And so again, anytime bonds are broken, energy is absorbed. Very important. Now, the energy released in making all the bonds of that are in the product is a sum of all the average bond energies, and this is an exothermic process. So energy is being released when bonds are formed, and so this is really important. Energy is being absorbed when bonds are broken. Energy is being released when bonds are formed. Now, the overall enthalpy change, or delta H, the change in the enthalpy of a reaction, relates to the bonds breaking and the bonds being formed. And so the total enthalpy change can be negative, which is exothermic, or positive, which is endothermic, which we talked about in the thermochemical equation notes, depending on the relative magnitude of the two processes, which is the breaking and forming of bonds. And so essentially, if it requires more energy to break the bonds than energy released when the bonds are formed, that's an endothermic process. It requires more energy to break the bonds than the bonds that are formed. Now, if it requires fewer energy, a smaller amount of energy to break the bonds, then the amount of energy given off when new bonds are formed, that's an exothermic process. And so let's go ahead and dive into that a little bit more. So the enthalpy change, which is delta H, for a reaction can be calculated from a list of bond energies and the following equation on the bottom here. Now, I will go through some examples of how to calculate this. However, the overall thing, the thing you need to really know is you need to understand if something is exothermic, that means the energy it takes to, or the energy given off when bonds are formed is greater than the energy it takes to break the bonds. And if a chemical reaction is endothermic, that means the energy it takes to break the bonds is greater than the energy given off from the formation of bonds. Now, here is a list of those bond energies. And again, when we go through some of these guided practice problems, I'm going to go and explain how the bond energies relate to determining whether or not something is endothermic or exothermic. So that's it. So go ahead and watch that guided practice problem video. Come to class with questions, but I do want to go ahead and give a brief overview of what we just talked about. Again, bonds breaking is endothermic, bonds forming is exothermic. In a reaction that is an endothermic reaction means that the energy it takes to break the bonds is greater than the energy released when bonds are formed. A exothermic reaction is the opposite. The energy given off when bonds are formed is greater than the energy it took to break the bonds. So let's go ahead and do some of those practice problems, and we will